Okay, let's look at this example of making the hybridized structure of xenon difluoride. And this is as an example of sp3 hybridization. Okay, so as usual, we are going to first count the total number of valence electrons. So total valence electrons, xenon has 8 valence electrons, right? And there is fluorines. So there's one xenon and 2 fluorines, and each fluorine is bringing 7 electrons, and there are 2 fluorines, and there is only 1 xenon. So we have here now 8 plus 14, and that gives you a total of 22 electrons. Okay, 22 valence electrons. Next is, since xenon, remember from one of our previous lectures, that there is a possibility xenon can make 2, 4, and 6 bonds also in very specialized conditions, because xenon has, you know, a d orbitals, and those electrons can be internally jumped, and they can cause these hybridizations and so forth. So let's just look at now that xenon, we know, will only can make, yes, xenon, you know, under very specialized conditions, can make 2, 4, and 6 bonds. Okay, fluorine, on the other hand, will only make 1 bond. So therefore, xenon is going to be in the center. So the central atom is xenon. Okay, now let's do the Lewis structure of this guy, xenon. So xenon is in the middle, and the 2 fluorines are on the side. So 1 fluorine here, another fluorine here, right? And now you connect them with a single bond, and out of the we have used 1, 2, 3, 4 electrons have been used. So we are left with 18 electrons, right? So where are you going to put the remaining 18? So remaining 18, yeah. So first put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay, so it's not like, it's not going to be linear though. Here, it will be a little bit bent, because see, this would be a little bit bent. Okay, so like that. So that is the shape, the Lewis shape, the Lewis structure of xenon difluoride. And if you count the total number of valence electrons, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. You look at the fluorines on both the sides, their octets are met too. And fluorine only wants to make 1 bond, you know, so fluorine is making 1 bond. Xenon is defying the octet, right? And in this case, xenon is making the 2 bonds, which, you know, it has the capacity to do. So it is doing that. So here we have the scenario now. So now let's count the total number of the electron groups. So we see the electron groups on xenon and on fluorine. So xenon has 1. So remember that these are also considered to be an electron group. These are also electron groups. Okay, so as we covered it, let me just go back. So if there is a lone pair, the lone pair is also considered as 1 electron group, right? So if there is a single bond, yes, it is considered as 1 electron group. Double bond is 1 electron group, triple is 1, but the lone pair is 1 electron group. Okay, so on xenon, we see there are 3 electron groups on xenon, which are coming from the lone pairs. Okay, the lone pairs constitute, you know, 3 electron groups, and there are 2 electron groups on xenon, which is coming from 2 single bonds on either side with fluorine. So this is one piece with regards to xenon. Okay, now let's look at fluorine. Fluorine, on the other hand, let's just remove that. So fluorine, on the other hand, has 3 lone pairs. 3 electron groups are coming from the lone pairs, right? The one lone pair is considered to be one electron group, and it is forming one single bond. And so one electron group is coming from one single bond with xenon. So fluorine has a total of 4 electron groups on fluorine, and we see 5 electron groups on xenon. All right, so 5 electron groups, 5 electron groups on xenon. Okay, electron groups. Okay, now remember that these electron groups, they constitute these electron groups, they constitute a certain type of hybridization. So if there are 4 electron groups, then it is sp3 hybridization and the shape is tetrahedral. So each of the fluorines is sp3 hybridized. And if there are 5 electron groups, then it is sp3d hybridization and it is trigonal bipyramidal. So let's look at this. Xenon is 5. Let's put this here. Xenon has 5 electron groups, and these 5 electron groups relate to sp3d hybridization and hybridization. I'm going to just raise it, and that is equal to, and then there are going to be 5 lobes, and the shape is going to be trigonal bipyramidal, like 2 pyramids, one on top of each other. Okay, so that's one piece. Next is the fluorine. Fluorine has 4 electron groups, and these relate to sp3 hybridization, right? And that means 4 electron groups means 4 lobes, and this relates to tetrahedral. So everything you need to know about, making these molecules, the structures, all this comes from basically writing the right Lewis structure and then getting the right electron groups, and everything else falls in place after that. Okay, so let's start doing this now. I'm not doing the energy diagrams here. I'm going to just straight away draw this. So here is the xenon, and xenon has 5 electron groups. Remember that we talked about 5 electron groups means 5 lobes, and those 5 lobes are what? Like a pierced pizza, like a pizza that has been pierced. So, we discussed that already. I don't have to write this again. But anyways, so here is the one lobe, one direction, another lobe, another direction, third lobe is in third direction, and then one lobe, this is the pierce. I'm making this bigger, sorry. All of them have to be the same, size, like that. Like somewhat like that. Okay, now here's an interesting part. Remember, the lone pairs do not like the bonded atoms, right? So fine, this is your xenon, which has a total of 1, 2, 3, 4, 5, 6, 7, and 8 electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, now comes fluorine. Now is, one second, let me bring this down so I have more space. Now remember that each of the fluorine is sp3 hybridized. And so the thing with the fluorine is that we cannot make, fluorine, each, let's put it here, fluorine is 1, 1, 2, and 3. Now here is the scenario with the fluorine. 1 electron here, and then you have to put this is that 1 electron. Okay, this is the 1 electron of fluorine. This is the other electron of xenon. So the other electron of xenon, which is unpaired, top and bottom, they will occupy the top and bottom, because according to the Vesper theory, the bonded atoms, they push the lone pairs, they push the bonded atoms as far away from them. So in a 3D, the lone pairs, they occupy their own exclusive spot, and the bonded angles have to take, like, a spot where there is least repulsion, and that is like away from them. So that's the best, arrangement right here. I mean, you can put it the other way around also, like you could do it the other way around also, but for space, I made it like that. But anyways, so here is the fluorine. Fluorine has 1, 2, 3, 4, 5, 6 electrons that are in the lone pair. So where are they? They are right here. 1, 2, 3, 4, 5, 6. So 6 electrons in 3 lone pairs, arranged like this. Okay, and then 1 is unpaired. So anyways, if you look at fluorine, 1, 2, 3, 4, 5, 6, 7. So this is what they look like. So this is their thing. Okay, so now you're going to bring in one fluorine here and another fluorine here. This fluorine brings its one lobe, and the 3 lobes are like in a tetrahedral shape away. This one also brings its 1 lobe, and the other lobes are away. They should be the same size, at least. Let me see if I can make it the same size. Sorry about that. So here is the fluorine. And this lobe is okay, like that. Okay, so these are the lone pairs of fluorine. 1, 2, 3, 4, 5, 6. The 6 ones, 6 electrons in 3 lone pairs. These are the ones right here, shown like this, and that, and this one. Okay, and then same story here. Fluorines are sp3 hybridized. sp3 hybridized. Okay. The sp3 hybridization of fluorines are in this fashion. And now let's look at the pairing. And this guy has, fluorine is bringing 1 electron that is overlapping with the xenon. So now we have here one single bond, sigma bond, another sigma bond right here. So 2 sigma bonds are here. The rest of them are all lone pairs. Okay. So now comes the question, if you look at the shape on xenon, trigonal bipyramidal. Okay, so this is a very important piece here. Let me put this in a different color. This is okay. So if you look at the shape, this is the fluorines are occupying the top and the bottom, and the lone pairs are flat on the flat side. So the shape is like a pyramid. So like, it looks like a pyramid. So one pyramid on top of the other. So more or less like that. So something, similar to something on this line, so trigonal bipyramidal. So fluorine is here on this. This is the fluorine, and this is the other fluorine. And xenon is somewhere hidden inside. And then this is one lone pair, this is another lone pair, and this is the third lone pair of fluorine on xenon. Okay, so like that, pyramidal is that's okay. So did we use all the electrons? If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. All the 22 electrons have been used. 22 electrons and 22 electrons. Okay, so that's the electron group geometry, trigonal bipyramidal. So if you look at now the I just want to do this molecule or type, molecule type. So this is A is xenon, AX is fluorine, and E is the lone pairs, and that is on the central atom. Shape is always, with respect to the central atom. So here is A, so it is A, X, 2, E, 3. 3 lone pairs. Molecule type is always, like we said, that with respect to central atoms. With respect to central atoms, sorry. With respect, with respect to central atom, and that's always the shape is that, and that central atom is xenon. Okay, so here this becomes AX2E3 is, what does this relate to? So here we have AX2E3. AX2E3 is here. So this one. So 5 stands for the total number of electron groups. We already calculated that. So on xenon, 5 electron groups, 2 bonded atoms, 3 lone pairs, relates to trigonal bipyramidal. And yeah, a molecular shape would be linear. Like from outside, we won't be able to see the lone pairs. So it's flat, linear, but really, if we count that, it's the real shape internally is trigonal bipyramidal. So this table and the handout that I have made for you, this one, very handy. You should, keep them with you and print them out. Okay. All right. So this is what we have now. What else is there? Next video we're going to do for sp3d2. Okay. So I'm going to stop this now and thank you for watching. Bye.